Okay, so how is everyone today? Good? Very good. Okay, come into focus thing. Sometimes you got to put something with sharp edges so it can focus. You can do it. Oh, come now. Cooperate, please. There we go. Yeah. Okay. All right. So last time we were talking about radicals. We've got one more minor thing to say before moving to the next item. So here's a bit of new notation. Is we can say, okay, let n be in the naturals with n greater than or equal to 2, and let x be in the reals. So what we're going to write down is just a synonym, another way to say something that you already know. So when we write x with exponent 1 over n, that means, that's another way to say nth root of x. Now, because nth root of x, nth radical, has parity behavior, meaning that the even case is one way and the odd case is the other way. That means that this one has exactly the same behavior. Okay, because this is a definition. All right. So as a result, we could write something like the following. I could say, how about what is 8 to exponent 1/3? So in the first place, how do you write that as a radical? Cube root, right? So you could say, you're asking about the cube root of 8. And then you could answer the question. So what is it? It'd be 2, right? So then, alternatively, I could ask, well, what about, say, negative 32 raised to exponent 1/5? All right. So which radical are we talking about? Fifth radical, right? So this is a fifth root of negative 32. So anytime you see a negative inside of a radical, you need to have a moment's pause and confirm or deny, is it permitted? So is it permitted in this case? It is. Now why is it okay in this case? Because the parity is odd, right? So even radicals, like fourth root, you cannot plug in negative numbers, but you can for odd ones. So what's the answer in this case? Negative 2. Negative 2 because if you were to do it, so negative 2 multiplied by negative 2 multiplied by negative 2 multiplied by negative 2 multiplied by negative 2. So you write out 5 of those negative 2's and multiply them all together. Well, this first pair, that's 4. The second pair, that's a 4. So that's 16. And then multiplied by that last 2 is negative 32. All right, good. Finally, how about negative 16 raised to exponent 1/4? Very good. Why is that? Right, because this radical in this case means fourth radical, and then that means that what was requested is by definition this, but that's an even radical, and even radicals cannot have negative inputs. So the correct response is to say that this is undefined. All right. So that means that concerning x to exponents, like that, so like x to whatever, now we know how to do x to any natural. Okay, so x to 5, we know what that means. We can do, in fact, x to any integer, because if the exponent happens to be negative, like, for example, x to negative 3, well, that means 1 over x to 3. That's what that means. Okay, so we can do, in fact, exponents are any integer. Now, in addition to exponents being any integer, we can do exponents which are 1 over any natural, besides 0, because 1 over 0 is just not defined. But we could also do negative 1 over any natural just by doing the reciprocal thing. Okay? So now, what we want to do is we want to be able to have any rational exponent. So what is a rational number again? Is that? Yeah, it's the PQ thing. So it's numbers of the form P over Q, where P and Q are integers, and Q is not 0. Okay. So we could say this: let m divided by n be in the rationals, which are denoted by Q for quotient, which are in the rationals with m and n are in the integers. Okay, n not 0, etc. But now we need one more. Besides all those things, we also need something else. We need m over n to be simplified. And m over n is simplified. What that means is it's something like this. So 2 over 3, that's simplified because 2 and 3 share no common factors. But 20 over 30, that's not simplified because they share a common factor of 10. Okay. So now what we're going to do is we're going to define the following. We'll define x to exponent m over n. So that means that now we're talking about something like x to exponent 2 over 3. Okay? The definition of this is x to 1 over n, like that. And then you do the m. Okay, which is to say, you could write this in another way. You could write it like this. You could say, well, when you're doing x to m over n, whatever the denominator is, you're supposed to do that radical and do that first, like that. And then once you've computed that radical, then you take all of that and raise it to exponent m. All right, let's see how that definition works. So for example, 8 to exponent 2/3. So that really means that we've got to do two things, one after the other, and the first thing has to be first. So so what are we supposed to do first? Yeah. So the first thing is to say that this is 8 to exponent 1/3. That's what we're going to do. And then after you calculate that, you're supposed to square the result. Well, what is 8 to 1/3? It's the cube root of 8, which is 2. So that means that this is 2, like that, to exponent 2. So all I did was just copied those big parentheses there, and then what goes in there is that 2. And then now 2 squared, okay, that's 4. Any question about this one? Yes?
So, just for my own clarification, before you get to the solved problem F4, you could also write it literally as the cube root 8 in parentheses,
Right. Yes. If you desired, you could put in this intermediate step where you say that this is the cube root of 8 and square that. Yeah, you could do that. Other questions? All right. Fine. How about, so, you know, that's maybe example 1. Example 2, something like negative 27 to exponent 4/3. All right. How do we do that? Right. So again, because it's this rational exponent, that means that you know, it's got a numerator and a denominator. We've got to do two things, one after the other. Essentially, you've got to address the denominator first. So that means that we have to do cube root first. So negative 27 exponent 1/3, like so, and then after we've done that, we'll raise it all to exponent 4. And if you were so inclined, you could write cube root like so. Okay, so I see a negative inside of a radical, so is that okay?
Yes.
Yes, in this case, because 3 is odd. So what is the cube root of negative 27? Negative 3. Because negative 3 times negative 3 is positive 9, multiplied by 1 more negative 3 is negative 27. So this would be negative 3 like that, and then raised to exponent 4. Okay, so what's that? 81. Any question about that? So again, you know, when this kind of question is asked, you know, the instructions say you've got to essentially do it this way. Okay, which is to say you've got to show these steps. Yes?
This is unrelated to the problem,
Uh-huh.
but the written assignment 03,
Yeah?
it's due on Monday, but there's no class on Monday.
Yeah, someone pointed that out. Yeah, obviously there's no, well, maybe not obvious, because I didn't realize, but there's no class on Monday, yet at the present time the written homework says it's due on Monday. Of course, that's not, that can't work. So they're going to be due on Wednesday.
So there's nothing due on Friday?
No, there is stuff due on Friday, I think. The 0-1 things, the stuff that starts with 0-1 is due Friday. She's talking about there's things that start with 0-3, so like 0-3-0 and things like that. They're at the present time they're said to be due on Monday. Yes.
But the online homework, that's still due.
Yeah, I mean, yeah, I guess there probably is one due Sunday night, right? No, wait, is there? Okay, I'm just gonna have to write this down, and I'll check it. At any rate, school is closed on Monday, and so some items on the schedule are going to be adjusted. I'll send a message. Put this down in my filing system here. Okay, good. Now, where your calculator is concerned, how do you type this into your calculator? The caret, right? So in most calculators, you write something like this: 8 caret, and then 2/3, 2 divide 3. So that's how you can get your calculator to play ball. So let's make sure that that really works. So 8 caret 2 divide 3. Okay, so then 4. Amazing. Now, that being said, you know, on such a question, what your work is what's required, right? I'm not interested in whether or not you can just type it into your calculator. Now, furthermore, how about this one? How would you type this one? Yeah, you'd have to put parentheses around it. So this would be, you know, to type this one, it would be negative 27, and then caret 4 divide 3, like that. Let's type that into the thing. Okay, so I typed it there. That one parentheses is over there. So there I typed it. And now what's it going to say? It's going to say, well, the reason why is because this calculator essentially does not know what a rational number is in the sense that we know. What it actually does is it takes that, what it does first, because of the order of operations, is it takes that 4/3 there, because it's in parentheses, and calculates it, and gets something like 1.33333333, etc. Okay, and then there's some notion of parity related to that. Okay, and the calculator essentially understands that to be even somehow. So you can't put a negative in there, but that's just a limitation of the calculator. Okay, it's the calculator not you've got to understand the limitations of the tool that you have. So I don't want to predict the future, not make no like claim that I can, but nevertheless, statistically speaking, not a significant, but a notable fraction of college algebra students are going to receive a question like this and tell me that it's undefined because their calculator says so. Okay. Good. So now let's move on to the next thing. So any questions? All right. So now we're in section 1.4. And it's called something like polynomials. So now to make the discussion, this discussion here, efficient, and the rest of the semester, because we're gonna deal with polynomials all semester, we need to have some terminology, some jargon. And jargon is just a nice vocabulary word which refers to the set of vocabulary words that are used in specialized context. So in a math class, there's all kinds of jargon, just like in general life. Like if you get a big cut, you injure yourself, and then you go to the doctor, you might say to your friend, you might say something like, I had to get 7 stitches. But the doctors don't call them stitches. What do they call them? They call them sutures, right? That's their name for those things. And then folks on the street call them stitches. Okay, but the physicians want to call them sutures. They've got special names for all the various stuff. That's jargon. Okay, so what we're about to say here is some jargon, and y'all are going to have to know it because I'm going to start using it quickly and without apology. All right. So the first thing that we're going to define is a term. So terms are the items in an expression separated by pluses and minuses. So, for example, we could write something like this. We could write 13x, 13 multiplied by x, and plus 14, like that. So that's an expression, and it has 2 terms in it. Okay, there's one term, and there's another term. So you can essentially, just sort of like notice that there's no other pluses and minuses. You can just kind of cover that one up. Okay, I must be covering a term there. And I see that there's a multiply there, but no pluses, so you can just cover that up and say, oh, that must be another term. So this is an expression with 2 terms. Understand that we could have a different thing, like z squared. So that taken just all by itself, okay, that's just a single term, just one term there. Okay. A similar word, but distinct, is factor. So factors are items in a term. Separated by multiply and divide. So continuing with that one up there, I could write, say, 13 multiplied by x plus 14. So this expression has two terms. And concerning the left term, how many factors does it have? Two factors, right? One of the factors is 13. The other factor is x. Okay? So then, so it has two factors. And you need to understand that, you know, given an expression, you can perform different simplifications to it. You know, for example, that 14 there, that's a single term. But, you know, we could have written it as like 1 plus 13. And, you know, then there'd be more terms. Or we could have written it as 1 plus 1 plus 1 plus 1, 13 times, you know. Similarly, here's a 14, but there's, you know, there's other ways to express 14, factorizations of 14. How can you factor 14? Right, 7 times 2. So as written, how many factors are there? 1 currently. But you could also write it as 2 multiplied by 7, and then that would be a representation that has 2 factors. Okay? Okay, any questions so far? So now, the thing I want to caution you on is that I find that most YouTube math videos and a lot of tutoring that I've heard, people, you know, like in the hallway, just like when I'm walking by, there's a lot of confusion about these. And what I hear is that most people just say term, like for both of these. But you need to understand that when I say term, I mean term, and when I say factor, I mean factor. Okay, so it means something definite. All right. Then now we have a definition of a polynomial term. So now I can say let n be in the naturals, a in the reals, and x is a variable. Which is to say that we're going to write some expressions and they're going to have x's in it, and that's a place where you could plug something in, like a real number. Okay? Then now there's two aspects to this definition. So the first possibility is that what's the least natural? 0. So we're going to deal with that one separately. So in the case that n is 0, what we're going to say is that the expression just a, all by itself, like that constant. So since a is real, you know, you can imagine that maybe we selected like like 4. So a all by itself, that's a term, a polynomial term, I mean. Such a term is referred to as a constant term. It's called constant because the other possibility is that n is more than 0, and in this case, polynomial terms take the form a multiplied by x to exponent n. So now such terms that look like this, a multiplied by x to exponent n, they're not constant because they have x's in them. Okay, so these are non-constant terms. Now, as for the a in the end, they each have a special name so that we can refer to them. The a on such a term is called a coefficient. E coefficient, that's an E. Okay, and then n for that term is called its degree. So, to make an example, I could say something like, well, how about 13 multiplied by x to exponent 14? All right. So in the first place, is this a polynomial term? So it is? Okay. So I agree. Now what's its coefficient? 13. And what's its degree? Okay, how about say x cubed? Is that a polynomial term? So is it? Essentially, you have to kind of ask, does it fit one of these patterns? Okay, and I sympathize with the no's, but the answer is yes. So for the no's, why are you saying no?
Because there's not like an A right there.
Okay, because there's not an A. Okay, I get that, but there's an implied A of 1, right? There's an implied A. So so that being the case, it is a polynomial term. What's its coefficient? It's 1. And what's its degree? Its degree 3. All right. Continuing this example. How about 5 multiplied by x? So is that a polynomial term? Yes. What's its coefficient? 5. Like that. 5. What's its degree? 1. Because again, we didn't write the 1, but it's implied. How about something like 5 multiplied by the square root of x? Is that a polynomial term? Yeah, I mean, so we just, at the beginning of this lecture, we talked about how radicals can be written as fractional exponents, right? So what fractional exponent is this one? Okay, so let's write that down. So 5 multiplied by x to exponent half. Okay, so then now I'll ask the question again. Is this a polynomial term? It is not. And the reason why is a little subtle. So there's some restriction on the exponent. What must be true about it? It has to be natural. Is half natural? It isn't. Right? That's not like a value judgment. That's just asking, if it's in the set that contains 0, 1, 2, 3. It's not in there. So half is not a natural number. So this is not a polynomial term. So not a polynomial term because half is not in the naturals. Okay, and for that matter, for that matter, none of the radicals, right? So I could write like, you know, like 17th root of x or something. That one's not going to work either. Okay, what about this one? Square root of 3 multiplied by x squared. Is that a polynomial term? Got y'all all gun shy now. So I've heard yes and I've heard no. One of these is correct. Well, I mean, you got to look at the rules there, okay? So the first rule is saying that the exponent, the degree, needs to be natural. Well, if this is a polynomial term, then what would be its degree? It'd be 2, right? Well, is 2 natural?
Yes.
Okay, so it passes that condition. The next one is saying is that a, which we're calling the coefficient, needs to be a real, which is just to say it needs to be some number. Okay, so if this is a polynomial term, what's a? Square root of 3. Well, is square root of 3 some number? Yeah. Okay, so yes, this is a polynomial term. So basically, you know, in a class, you know, you've got to do both of these. You know, you got to. I mean, notice that I gave you 2 examples. Both of them had radicals in them. The issue is that this first one is not a polynomial term because the variable was inside of the radical, which made its exponent not be natural. Whereas in this case, there's a radical, but is the variable in there? It's not in there, right? So that's what makes this okay. So it's not. I want you to be sure not to think that radical bad. Okay. Okay, it's just you. Good. So so generally speaking, a polynomial is just a sum of polynomial terms. So that's all it is. You take a bunch of polynomial terms and you add them all together. Okay, so then, you know, to give some examples, how about, you know, 13 x squared minus 1x plus 4. So how many terms are in there? 3 terms. Is it the case that each one of them is a polynomial term? Okay, if no, then why not? Okay, well, that's this part of the definition. So there's 2 possibilities, and one of them is this one. So a constant is a polynomial term. Okay, and then as for these other ones, okay, they're polynomial terms. As a result, this is a polynomial. So you know, the question was, is it a poly? And the answer is yes. Okay, the next one I could say is, well, what about, you know, say like, I don't know, x cubed minus 4x plus the square root of x. So how many terms? So 3 terms. Okay, they're all terms, because terms are just things separated by pluses and minuses. They're all terms. The next question is that are they all polynomial terms? Okay, is that one a polynomial term?
Yes.
Yes, because its coefficient is 1 and its degree is 3. Is that a polynomial term? Yes, because its coefficient is negative 4. Right? And its degree is 1. Okay? So is that a polynomial term? It is not. Because when represented with exponents, this has exponent half. Okay, so then it's not a democracy, right? Or at least not in this. You might say, well, 2 out of 3 of them are polynomial terms. So, but they don't vote. In order to be a polynomial, all terms must be polynomial terms. Okay, so not a polynomial. In the end, because of this one term. Good. Any question about this? All right. So one thing that y'all knew before you got here is distribution. So specifically, distribution is when you do this. So A multiplied in parentheses B plus C. So now, because this is in a group, this is in a group, you can effectively like just cover that up and pretend you can't see what's in there. And then looking at it that way, this whole thing is a single term, okay, with how many factors? 2 factors, right? The one on the left and the one on the right, whatever it is I'm covering up. And then inside of here, because this is a group, you can, in a sense, just look at that and just only look at that. Inside of the group is 2 terms, okay, B and C. So 2 factors, 2 terms, and what distribution is, it says how these play together. And the way it works, it's called distribution because what happens is that the B receives an A and the C receives an A. So they both get an A. Terrific. So then you have A multiplied by B plus A multiplied by C. And the word distribution is chosen because it's like you're giving an A to the B and also to the C. So it's being given out. Okay. We can do things like that with polynomials. So let's have an example. How about 3 multiplied by x squared plus 6 multiplied by x to exponent 5 minus 8. And then to that, we'll add, something like, I don't know, x to exponent 5, subtract x to exponent 3, add 2 to exponent 2, like that. So inside of each group, inside of each set of parentheses, are polynomials. So that's a polynomial, and that thing itself is a polynomial. So we've got 2 polynomials, and I'm saying that, hey, did you know you can add polynomials? So where adding is concerned, to make it like in grade school, when you say like, like Alice has 5 apples and Bob has 4 apples, and if they combine them, then they've got 9 apples. But it doesn't make any sense to ask a question like, if Alice has 5 apples and Bob has 4 bananas, then if they combine them all together, how many giraffes do they have? Right, the question is like nonsense, right? Because the types don't agree. So what it means for polynomial terms to be the same is their degree. So what I want you to see is where like apples and oranges are concerned, this is a degree 2 term, so it's like its own kind of thing, and this is a degree 5 term, so it's its own kind of thing that's separate and apart from the degree 2 things. So what we want to do is add all these together. So the first thing I'll do is that you don't really have to do, but I just want to make sure that it's clear that you can just rewrite all of this without the parentheses. Okay, so I'm doing that. And then now we've got a bunch of terms all added together. Well, addition is commutative, which means you could put like things together. So the way that you do this generally is that you consider the highest degree first. So among all the terms, what's the highest possible degree that you see? 5. Okay. So there's a term of degree 5. Are there any other terms of degree 5? Yeah, that one too, right? So this is like asking if you have 6 apples and someone else has another apple, one of them, right? Then altogether how many? 7. Good. So 7 of those. Then now you, oops, I wrote a 6 there. That should be a 5. It did, when you add together apples, right? They don't like become oranges. So this should be a 5. And then now you just start counting downwards. Okay, so are there any degree 4 terms? No. There's none. Any degree 3? Okay, just that one. Are there, besides that one, any others? Nope. So then minus x cubed. Any degree 2 terms? Yeah, those two, right? So altogether there's 5 of those. And then any degree 1 terms? No degree 1s. What's that one? That's constant, right? So you might refer to it as degree 0 because it's got no x's in it. 0 x's are in it. So minus 8 there. Any question about this? All right. So besides that, we can also do this kind of lovely thing here. We can say, well, what if we have, how about 3x plus 4, and we want to multiply that by, say, 5x squared minus 8x plus 7. So we've got, the previous question was, well, what if you had 2 polynomials? How do you add them? Well, like this. Now we're saying, what if we have 2 polynomials? How do you multiply them? So you've got to do it with distribution. So in fact, we're going to have to do many distributions. So this thing is, depending on what textbook you're reading, this is either called a left distribution or a right distribution. So at any rate, the A is on the left-hand side. So some folks, because the A is over there, call it a left distribution. But because the A is kind of like moving to the right, some folks call it a right distribution. At any rate, it doesn't matter. What I want you to see is that we need to either start with left or right. We have to start somewhere. So do you want to do these to those, or so these ones on the left to the ones on the right, or the other way? The first way? Okay, it makes no difference, really. So this will go to that one, and that one, and that one. So what that's saying is that we'll do 3 times x plus 4 is going to be multiplied by 5x squared, and then now we'll subtract. 3 times x plus 4 is going to be multiplied by 8x. And then 3 times x plus 4 is going to be multiplied by 7. So what I want you to see is that I'm just covering up that thing that was just distributed, right? We distributed these things right here to each one of those 3 terms. Okay, so here's the first term got it, the second term got it, and I remember the subtraction there, and then the third term got it.
So would it be -8?
Well, you could say you could have made that plus and made that -8 there. Somehow the negative has to not be forgotten. Okay, good. So now concerning just this part here, can you see what will we have to do? A distribution, right? so now we're going to distribute, but going that way, right? Okay. So like this, and this is going to go that way, and this thing is going to go that way, and that way. So carrying it out, all right, what is 5x squared multiplied by 3x? It'd be 15x cubed. Now, for this one, I'm going to do it. I'm going to write it all out so that you can see it. But just this one, because I think you can probably imagine the rest. So if you just multiply them all, if you just write them side by side, because you're saying multiply that one by that one, notice that we've got a 3 and a 5. There's 1x, and then there's 2 more, because that's xx. Now you can imagine just commuting all the things to be side by side. When the 3 and the 5 are side by side, that's 15. And then when it's xxx, that's x cubed. Right? Okay, so similarly, this times that would be 20x squared. Okay, now let's do this distribution. So now I'm going to make an error that's very common. Okay, so I'm going to do this distribution. So 8x times 3x is what? So 8x times 3x. When you get the 8 and the 3 together, what's that? 24. And then when you get the x's together, that's x squared. Okay, and then now I'll add that times that would be 32x. Okay, and there's an error on the page currently. So then now I'll add 21x and then plus 28. So what error is on the page? Right. Because notice that this is saying that we are supposed to subtract all of that business. Right? It's not saying just some of it. You got to subtract all of it. So you can imagine that there's like some parentheses here. And where would these green parentheses belong down here? Right there, right? So before I put those green parentheses, we were adding the 32x. But in fact, we need to subtract it. So then, are we out of time? I hear y'all packing. We're just about, I've got another 30 seconds. Okay, so then what you do so I'm just going to do it real quick. So this would be 15 x cubed plus 20x squared subtract 24x squared subtract 32x plus 21x plus 28. So now we just finally need to collect. So what's the highest degree?
13.
Okay. So, and there's just one of them. So are there any degree 2 terms? Yeah, those. So altogether there's -4 of those. So -4x squareds. Are there any degree 1 terms? Yes. So this many. So altogether that's how many? -11? No, is that right? I can't do arithmetic. Yeah, okay, good. -11. Of those. And then are there any constants? Yeah, that one, right? Good. All right. Have a wonderful Wednesday.